enthalpy H. Before this I told you about the entropy, and now I will talk about the enthalpy. The term enthalpy has been taken from the Greek word, the thalpos, which means the warmth or the heat. It means that the enthalpy is related to the heat content. Heat content. In a system. Denoted by H. The enthalpy is purely heat content at constant pressure. So now this H equal to enthalpy is the sum of internal energy and product of pressure and volume of the system. It means that this enthalpy H equal to U plus PV. This is what the formula for this enthalpy, and enthalpy is simply the heat. So its unit is joule or kilocalorie, and its dimension are M1 L2 T minus 2. Dimensions of energy or dimensions of the work, that is the dimension of the enthalpy. enthalpy of homogeneous system. Homogeneous system depends upon size of system. It means that this enthalpy of homogeneous system is proportional to size of system. This is for homogeneous system, because the homogeneous system has the same structure at all points inside it. But if we take the heterogeneous system, for heterogeneous system, this H equal to summation over K into HK. So this K equal to 1, 2, 3, 4 and so on. Since the heterogeneous system is not uniform, so it has the different parts of the different one. So we sum up the enthalpy of all the states of the system. So this we have taken the K that varies from 1 to onwards. Suppose the heterogeneous system contains contains the 2, 3, 4, 5 and so many other parts which are different one. Then we take the sum of all the enthalpies of the different parts of the system. So this is now enthalpy in case of the heterogeneous system. First law of thermodynamics. This now delta Q is equal to du plus PdV. Now enthalpy. Enthalpy dH equal to du plus dPV. So now what we have, this is equal to du plus P dV plus V dP. So now put the value of du from in this equation. This is equal to du, or sorry, this is not dH, or this du is equal to dH minus P dV plus minus V dP. So from now this is 1, now put du in equation 1. What we have? This delta Q is equal to dH minus P dV minus V dP plus P dV. So P dV and P dV will cancel. So this delta Q is equal to dH minus V dP. Now in place of dq, we can write down this TdS. Or dH equal to delta Q plus V dP. Now from second law of thermodynamics, dH equal to T ds plus V dP, where delta Q equal to T ds. The ds, that is the change in entropy of the system. So this gives the relation between the enthalpy, the entropy and the pressure and volume. So now you can see from here that if this P is constant, then this dH equal to TdS. At constant pressure, now this dH is equal to TdS, because this dP is equal to 0. So TdS is equal to delta Q. So dH equal to, this is now your delta Q and this is now your Cp dt. This is now your dH, where Cp specific heat at constant pressure, dt change in temperature. It shows that the change in enthalpy is totally related with the heat content of the system. It makes clear that enthalpy is related to heat content of the system. At constant pressure. So when pressure is constant, then dH equal to Cp dt. So this is the heat. So it means that whenever there is a change in enthalpy, then this is the change in the heat, or this enthalpy is related with the heat content in the system. heat given to system. It means that dH equal to positive. It means that the heat increases when the heat taken from system then this dH equal to negative. So now we can have that, suppose these are the two systems. This is system A and this is now system B. System A and this is now system B, and the heat is going like this. This is now heat. So this heat is flowing from system A to system B. So for this one, this dH equal to negative, and for this dH equal to positive, because heat is being taken from this system A, so dH is negative. Now this is the heat is given to the system B, or the heat is increasing of the system B, then this dH equal to positive. So the system which takes the heat from some other source, then its heat content increases, so the dH also increases. So this is what the meaning of positive and negative enthalpy. So now we can have that in case of exothermic reaction, Now in exothermic reaction, the heat is given by the system. So this dH equal to positive. The heat is given by the system in exothermic reaction, so dH equal to negative. And in endothermic reaction, dH equal to positive, because here the heat of the system increases, here the heat of the system decreases. So when this H decreases, then this dH is negative. Here the amount of heat increases, so this dH equal to positive. So in exothermic reaction, always heat is given by the system, and in case of endothermic reaction, heat is absorbed by the system. So when the heat is absorbed, then dH equal to positive. So this is about the enthalpy. The question is asked that what is the enthalpy, what is the for which physical quantity it is related, and what is the formula for this one, what is the unit, and what is the relation between the enthalpy and that the heat content, and that you can also have the reactions, the exothermic, endothermic. Then what is the enthalpy, whether this is negative or positive or zero. So this is all about the enthalpy of the system. So always remember that this enthalpy is related with the amount of heat content in the system, and the entropy is related to the randomness of the molecules in the system, or the chaos that increases with the increase of heat. So this is the difference between the entropy and the enthalpy. So thank you very much.